quiz today. I'm hoping everybody does step 1, factor and look for a hole. And then after you check for a hole, whether or not there is a hole, then you move on and you do set your denominator equal to 0, find your vertical asymptote, check for a horizontal asymptote. So this is all from yesterday. You compare the degrees of the numerator and the denominator. When the numerator's degree is less than the denominator, the horizontal asymptote is always y equals 0. The denominator will overtake. It will be so big, the numerator will not be able to catch up, that it will be close to 0. Okay. When the degrees are equal, then you use y equals a over c, which is the ratio of the leading coefficient. No matter what, like if they're both quadratics, no matter what you might be adding or subtracting on the back, it's like if you had like x squareds on the top and on the bottom, when you put like 1 million in and then you square it, those are just so big that they overtake everything, and then it is basically just like the ratio of the leading coefficients. Okay. And then this one yesterday, I put a little asterisk next to it, so that's what we're talking about today. For horizontal asymptote, you might check it, and if the degree of the numerator is greater than the degree of the denominator, you'll say it does not exist. Okay. If the degree of n of x, the numerator, is 1 more than the degree of g of x, then there is a slant asymptote. So this you should write down in your notes. G of x sort of got separated. Let's see if we can get it together. If the degree of the numerator is 1 more than the degree of the denominator, then there is a slant asymptote. So now we're thinking back to like maybe what we know from Algebra 2. We didn't know about holes in Algebra 2, and we didn't know about slant asymptotes either. So this is, I don't know, does Algebra 3 cover slant asymptotes, anybody? Remember, recall? Not sure. Okay, maybe not. I think that they may not, but okay, if you know there's a slant asymptote because the degree of the numerator is exactly 1 more than the degree of the denominator, then how do you find it? Well, you use division. Now, you could use long division or synthetic division. Of course, if you're going to use synthetic division, you need to be dividing by a linear factor in the denominator, so it would have to be like a quadratic over a linear. But I'll be real honest, I like doing mine with long division because then my quotient is just like at the top of my division bar, and it's just really easy for me to write the equation of my slant asymptote. So if you want to try synthetic, you can, but I'm going to show you it. I like to do it with long division. It's not very long, so it goes pretty quickly. And then the other important thing to note is that your slant asymptote is just going to be the quotient part of your division. There is no remainder that has anything to do with your slant asymptote. But it's very likely that there is some remainder. It's very likely that these two polynomials don't divide nicely. So you just kind of ignore the remainder. Okay. Now, slant asymptote is going to be a slanted line, so it should be of the form y equals mx plus b. I expect everybody in here to know what the equation of a line looks like. There it is. Okay, so when you write me slant asymptotes, does it look like a y equals mx plus b equation? Here's a couple, we'll do 2 examples. Okay. We'll start with f of x equals x squared minus 9 over x. Okay, if I were doing this problem like today, I would factor everything first, difference of perfect squares, nothing cancels, so there is no hole. I could do my vertical asymptote, set my denominator equal to 0. There's 1 at the y-axis, x equals 0. For the horizontal asymptote, the degree of the numerator is 1 more than the degree of the denominator. It does not exist. Okay. But because this one is quadratic and this one is linear, I know there is a slant asymptote. So how do I find the slant asymptote? Divide. X squared plus 0x minus 9 divided by x. should be pretty painless here. X squared divided by x. Thank you. X times x. X squared. Then I subtract, and those disappear, right? So I would really have to bring down my 0x and maybe my 9 in order to be able to keep dividing. Well, what's 0x divided by x? 0. Okay. Everything else after this is part of the remainder because I've hit the end of division, right? I know that. This is my quotient. Everything else goes back on as a remainder, and I don't care about the remainder. So my slant asymptote is y equals x plus 0, which I would just write as y equals x. If you write y equals x plus 0, that's fine. Don't care what the remainder is, can stop in the middle of my division. Okay. And then I could go on if I want to find intercepts or if I want to find some more points before I plot them. Okay, let's do this next example. X cubed plus 2x squared minus 2x minus 4 all over x squared plus 3x plus 2. Well, really, I'm going to run through the same steps as yesterday. Note, the only time I change my step is if I answer horizontal asymptote does not exist, then I check for a slant asymptote. Okay. So I'm going to factor everything. This numerator is 4 terms, so I'm going to check it with factor by grouping. I can take an x squared out of the first 2 terms and a negative 2 out of the last 2 terms. Does that factor by grouping? Yes, because the parentheses match, x plus 2. Okay, so it's really x plus 2 times x squared minus 2. Okay, and then in the denominator, this one's nice and easy, x plus 1, x plus 2. So you notice there is a hole. Okay, so I would go about my merry way. What's my hole? Let's see, the 2's cancel. So I have a hole at negative 2, because that's the 0 of x plus 2. I could plug negative 2 in, so I'll get 4 minus 2, which is 2. And then negative 2 plus 1 would be negative 1, so what is that, negative 2? A hole at negative 2, negative 2. And I'm kind of going through that part fast because that's from yesterday, right? We know how to plug in. I could go vertical asymptote is x equals negative 1, set my remaining factor in the denominator equal to 0. Horizontal asymptote, in the numerator I have an x squared minus 2, in the denominator I have an x plus 1. Okay, so if you want to write this out, this is x squared minus 2 over x plus 1, that's the simplified version, right? So we would say for a horizontal asymptote, does not exist, right? The numerator is bigger than the denominator degree. But since it's exactly 1 more, I'm going to divide and check for my slant asymptote. Okay. So x squared plus 0x minus 2 and divide by x plus 1. I like to do it long division because then my top part is just the equation of a line. I just have to put a y equals in front of it. All right, x squared divided by x. X. X times x is x squared. X times 1 is 1x. Subtract both parts. That's negative x minus 2. I haven't finished my division because I'm not at the end of the division bar up there, so I'm going to do, what's negative x divided by x? Negative 1. Now that I put that constant up there, everything else is part of a remainder. Don't care. My slant asymptote is y equals x minus 1. So that slant asymptote, I have to go down 1 on the y-axis And my slope would be positive 1, so I could go up 1, right 1, up 1, right 1, and I would draw a dotted line. That would be a slanted asymptote. Okay? So your homework assignment for tonight is this worksheet that I'm going to give you, and all I really want you to do tonight, you can attempt more if you would like, but we're gonna graph together tomorrow with a slanted asymptote. The main thing you want to practice tonight is, can you run through those first steps from yesterday? Can you do the whole, the vertical asymptote, the horizontal asymptote, and if there is no horizontal asymptote, check a slant asymptote.